Good afternoon, guys.
Good afternoon, sir.
Good
Afternoon,
afternoon.
sir.
Okay ra ang sound? Maklaro ra ba akong tingog? Okay,
Yes, sir.
okay, thank you. Akong kuan kamera wala kay daot man akong kamera, no? Kapuyan ko maggamit pog cellphone and then desktop pod kas kay og load, no? Aside from kas sa load, dili magkadimaw ang ila, dili mag-synchronize ang signal, no? Kaya lain ako ang lain akong gamit sa phone, data akong gigamit. Okay, so anyway, pila ba ta ka buok? 39 ta ka buok, no? So at least doon na 20, 21 ka buok ang ato ang attendance. And then okay, we will start first with a prayer, no? Okay, in the name of the Father, and of the Son, and of the Holy Spirit. Amen. Come, Holy Spirit, divine creator, true source of light and fountain of wisdom. Pour forth your brilliance upon us, our dense intellect, dissipate the darkness which covers us, that of sin and of ignorance. Grant us a penetrating mind to understand, a retentive memory, a method and ease in learning, the lucidity to comprehend, and abundant grace in expressing ourselves. Guide the beginning of our work, direct its progress, and bring it to successful completion. This we ask through Jesus Christ, through God and through men, living and reigning with you and the Father forever and ever. Amen. Again, good afternoon, guys. Okay, wait. We'll have our attendance first. Um, please open your microphone. Today is April 6. Abarkis, absent. Abrasaldo, absent also. Anchita wala.
Present,
Arong,
sir.
Anchita na Hili?
Present po.
Okay.
Na, sir.
Okay. Arong,
Present, sir.
thank you. Barrios, Kevin. Bilbistre.
Present, sir.
Murag ako man estudyante Bilbistre. Kanyete. Kanyete po dog si Abarkis. Murag ako ni mga estudyante. Kanyete. Wala, absent sad. Caballero.
Present, sir.
Sanyaris.
Present, sir.
Clemente. Julius.
Present, Kuya, sir.
Sir,
Clemente, sir.
Si Saron, si
Clemente, sir.
Clemente. Okay. Makita man ninyo, no? Makita nyo sa inyong side.
Yes, sir.
Dakay. Dakay, wala. Kuyos natos Kuyos, no?
Yes, sir.
Daduig.
Present, sir.
Iglasa.
Present, sir.
Sinopol. Jade.
present, sir.
Durham. Wala si Durham. John Scario.
Present, sir.
Musta na dyan? Juberus Fabric. Absent ni. Figueroa. Delina.
Excuse me, sir. Present si Fabrique, sir. Kanang guba iya microphone, sir.
Okay. Fabrique ni o Fabric? Fabrique no?
Fabrique. Yes, sir.
Okay. Gilina. Gilina.
Present,
Risha.
sir.
Sa'yo pronounce mong name? Risha. Ay, family name?
Galiana, sir.
Gilina. Okay, thank you. Harina.
Present, sir.
Kuma.
Present, sir.
Pando.
Excuse me, sir. Figueroa.
Present, sir.
Figueroa. Naa, sige. Luwab. Absent Luwab. Lumibaw.
Present, sir.
Miuli. Miuli. Samantha. Murok.
Present, sir.
Anak, murok.
Present, sir.
Okay, daghang manok. Diha, murok. Nervida. Nervida. Absent. Palis. Absent pod. Pito.
Excuse me, sir. Naa si
Yes.
Nervida, sir.
Nervida na. Palis, absent, no? Pipito, Sabin. Wala. Iris. Randas. Reponte.
Present, sir. Reponte.
Ruben.
Present, sir.
Sanoy.
Sir,
Sir,
present.
present.
Randas, sir.
Sir,
Sa
present. Rubin, sir.
Ruben na. Kinsa pa?
Yes,
Randas.
Randas, sir.
Sige, kinsa pa?
Si Perez, sir. Wala sa nadungog yung mic.
Perez. Who else? Kinsa pa?
Sir Durham, sir. Present, sir.
Dirham? Durham.
Opo.
Durham. Joshua, no?
Yes po.
Okay. Sanoy. Sinilio.
Present, sir.
Suson.
Sinilio.
Sinilio. Okay. Suson. Suson para. Toledo. Okay. Vergara.
Sir, present.
Present,
Sir.
Vergara.
Vergara na. Kisar torong laki. Si
Yes, sir.
Okay.
Dakay.
Oo, sir.
Okay. Vergara na. Toledo na. Toledo. Susun. Wapod, no? Yaon. Franklin.
Present, sir. Present, sir.
Okay. Mura mag-under ka Franklin sa P6 siguro, no? I'm not sure. Sa face-to-face pa ba, no? Wala ba? Kalimot naman ko. Pero mura mag mga estudyante na ko ng uban diri. Okay, wala na. Tanawan ninyo, makita man niyo din ha ang kuan, ang absent. Okay, ang importante sa atong attendance is that katong perfect ang attendance during the final sa ato ang score sa atong final exam mag-add ko og 20 points katong perfect, no? Dunay mga absent less than 2 absences 15 points. The rest wala na points, no? Okay? So one more thing about the attendance is that kung pirmi lang ka nga present pero alanganin imong grades, madapan nato na siya og inat, no? Madapan nato siya og ang sangin ani stretch, no? Kung perfect imong attendance, okay? So actually this ang atong attendance dili kayo mo matter sa atong grade pero doon natin mga extra points based sa atong attendance, no? Importante na kung attendance, double attendance ta, no? Duha to attendance during and after sa discussion, no? Okay, importante na dili kay ko magsalig sa atong i-download atong attendance kay dili kay siya reliable, no? Reliable ang atong attendance mo na. Okay, so that's it, no? We save this for a while. Okay, so let's proceed with our discussion. Now, actually, this is the first time I will be discussing or mentoring chemical reaction engineering online, no? Nagtudlo ako ani sa face to face lang, no? Medyo li kayo ko tingan ni sa online. I realize nga maglisod ko og buhat og kanang ani preparation ani, no, kay online kay everyday ang ato ang klase, no? Everyday din atong klase, no? May tatog ka ng dili lang everyday ang iyang klase kay makabuhat ang materials dayon. So what I'm going to do now is I'm going to find a video nga medyo kanang masabot yun ninyo, ma-relate sa ako ang discussion o akong i-discuss nasa YouTube or any other sources nga pwede na to ikahapag din na mas dali inyo makatunan. Anaon na lang nako kung makabuhat ko og materials din ako ako po di appeal, no? Pero for the meantime kung dili na ako ma-appeal, di ko kabuhat, mangita na lang og video nga mas duol sa ato ang para mas dali lang. Okay? Anyway, there are many sources sa materials sa ato ang sa video, no, especially the YouTube nga pwede na to gamiton nga sources. Okay? Another part is that atong exam quizzes will be every Monday. So dili ta mag-discuss ng Monday, mag-quiz ta na, no? The time gamiton nato sa ato ang may gamiton nato sa ato ang quiz. Real time man ang atong quizzes, okay? So at assignment, doon na po tayo assignment nga implement maybe by Wednesday or Thursday na to mahatag ang assignment. Depende lang, no, kung asa napitan topic nga mo. Doon na tayo assignment, no? Okay? Chemical reaction engineering is mostly designing reactor, no? Okay? So we will start by analyzing what is chemical reaction engineering. Actually, chemical reaction engineering is the heart of a chemical engineer. Diri gyud ang pinaka, not only the heart, no, the brain. Okay? This differentiate chemical laboratory technician or kanang nagtrabaho sa mga laboratory og sa engineer, no, chemical engineer, nag-differentiate sila because of this subject, no, chemical reaction engineering. In this part we are going to design a reactor, no, kung unsang klaseng reactor atong gamiton nga safe siya, then cheaper pud siya by economy, no, maayo siya nga gamiton nya daghang magud ang reactor, no, pero most probably ang atong gamiton daw upat nga klase, no. We will talk about that later, no. So mo ni ang nag-differentiate. Chemical reaction engineering is the heart or brain of chemical engineers. So mao gini ang ato ang mastero, no, 14 na to mag-design ta, no. Okay, we may be designing absorption column, no. We may be depende kung unsang klase, no, tanang klase nga mga no, nga mag-involve of chemical reaction, okay, in plant, no, in industry, not only in laboratory. Okay, so we will start, no. So chemical reaction engineering, so we're going to review the concept first of this reaction kinetics. We'll be talking about the classification of chemical reactions, the definition of reaction rate, and then later on we will do the mole balance, mag-review ta sa ato ang mole balance, no. But in this part dili na ta mo balik kung unsa na siyang molarity, dili na ta human ang tanan no. Ang ato din is medyo mas kuan siya, mas ato ta model sa katong mag-ana mo kahurot ang iyang number of moles no. Ato mo ta itong gamiton dito. Okay? So chemical reaction engineering as in the Wikipedia or in other source of books no, na pare-pareho ramang definition sa books o ang sa Wikipedia siguro gikuha lang na sa Wikipedia sa mga books no, sa chemical reaction engineering. I already posted the material sources like the Lebensfeld and the Fugler no. Duha man ka book ang pinaka-importante nga kuan sources atong chemical reaction engineering nasa ato ang module course module no. Okay, so chemical reaction engineering is a specialty in chemical engineering or industrial chemistry dealing with again as I said, dealing with chemical reactors. Okay, so that's it no. So mag-design gid ta og reactor. After this dapat katiguro ta mo design og chemical reactors. Okay, actually this is just the beginning no. Now chemical reaction engineering, frequently the term relates especially to catalytic reaction systems where either a homogeneous or heterogeneous catalyst is present in the reactor. Sometimes a reactor per se is not present by itself, but rather is integrated into a process. For example, in reactive separation vessels, retorts, certain fuel cells, and photocatalytic surfaces. So, sa gasa lang nato siya ma-deal, no? Pwede po nato siya ma-deal sa biochemistry, no? Biochemical engineering po. Pinapod nato ni ma-deal po nato siya din. Halos tanan, no? Ang involve of chemical reaction, whether it is inorganic or organic, swak din ang ato ang engineering kung mag-design ta og reactor. Okay? Kung ano nato diha dapita i-held ang usa ka reaction no sa mitabo basig mo butohin na tong design no kinahanglan na kategorya na ta mo design ani after this thing. So chemical reaction engineering as a discipline started in the early 1950s, okay, under the impulse of researchers at the Shell Amsterdam Research Center and the University of Delft. Actually ang chemical engineering gimugna lang ni siya sa mga mechanical engineers no. Ang mechanical engineers sa una mo gi mag-design no, sila mag-design sa mga reactor, sila magkuan na, pero maglisod sila no, maglisod sila sa bahin na sa pagkuan sa mga reaction no. Dunay part ka kulang sa mechanical engineering. That's why ang nagbugna sa chemical engineering ang mga mechanical engineers gyud ang nagmugna. Sila mo ay patukod no, they are the one making this chemical engineering no, because of this chemical reaction kanang mga reactions kanang mga reactor nga buhaton nila di sila naglisod. That's why gi-separate nila ang chemical engineering, and that's the part nga mao'y pinakalisod sa tanang mga courses sa engineering. Chemical engineering is the hardest course in engineering no, not to include the architecture is a different field man gyud na siya no. Sa mga engineering lang no, ang chemical engineering mo ay pinakalisod. Okay, so 1950s siya nya gi-start no. The term chemical reaction engineering was apparently coined by G.C. Vlogter no, while preparing the first European symposium on chemical reaction engineering, which was held in Amsterdam in 1957. Okay, so dugay na gyud no. So chemical reaction engineering aims at studying and optimizing chemical reactions in order to define the best reactor design. Okay, so that's it no. Okay, mag-design man tag reactor, so ang atong buhaton na niya atong i-optimize ang atong chemical reactions in order to define the best reactor. So kita man chemical engineer may magpili no, pag flow ba, batch type ba, or unsa di ana continuous type ba atong gamiton, depende na lang no, atong depende sa ato ang ma-design no. Ang pinaka nindot nga term gamiton dia is economy, no? Cheaper, then safer. Mao di siya atong butang sa atong una. Okay? Kanang duha ka term. So that was GC Blockter, no, ang nag-coin na niya. Okay, 1957. So chemical reaction engineering aims at studying and optimizing chemical reaction. Yan yung ato nang gibasa, no, na kini day. So hence the interactions of flow phenomena human naman tana naagi na siguro mana mass transfer human na sad siguro tana heat transfer human na sad siguro mo ana di man ta makakuha ng chemical reaction engineering kung wala ta mahumanan ni reaction kinetics, no, human na siguro pud tana, no. Okay, and most especially thermodynamics kina gid sila mo importante nga gamiton na nato in doing these things, no, in designing reactor, no, are of prime importance in order to relate reactor performance to feed composition and operating conditions. Although originally applied to the petroleum and petrochemical industries, ito nga time mao ni pinaka-boom, no. So mga mechanical engineer mao gi ga-design aning mga industries, no, ang petroleum petrochemical. That's why gi-separate nagbuhat jud og kanang field sa chemical engineering kay naglisod sila, no, sa reaction. Okay, now its general methodology combining reaction chemistry and chemical engineering concepts. So duha ka bug ang gigamit, no, methodology combining reaction chemistry, so chemical reaction, no, and chemical engineering concepts allows optimization of a variety of systems while modeling or engineering of reaction is needed. Okay, so that's it, no. So chemical reaction engineering approaches are indeed tailored for the development of new new processes, no, and the improvement of existing technologies. Okay, so wala siya kumana, no. Kada adlaw gyud mag-design, kada adlaw gyud mag-innovate, no, og mga reactor. Siguro karon sa pagkakaroon na arata nag-evolve sa kanang pinaka-importanteng upat ka reactor, no, nga which we will be dealing, no. Unya ang formula ana niya actually dili gyud kay siya ingon og nga nakalisod, no. Ang sayo naman din siya, no, yan depende na lang na sa how do we understand, no. Okay, so dahil mga technique ana niya. Okay, so one feature that distinguishes the chemical engineer from other types of engineers is the ability to analyze systems in which chemical reactions are occurring and to apply the results of his or her analysis in a manner that benefits the society, no. Consequently, chemical engineers must be well acquainted with the fundamentals of chemical reaction kinetics. Okay, so importante na siya, no. Before we can design things, kinahanglan kabalo ta ning chemical reaction kinetics. Okay, and the manner in which they are applied in reactor design. So that is the chemical reaction engineering. So this involves, okay, reactor design uses information, knowledge, and experience from a variety of areas, as we talk about these things just a while ago, no? Thermodynamics, chemical kinetics, fluid mechanics, heat transfer, mass transfers, and economics. So kini nga field mo ni kinahanglang masteron na to before ta maka-design or maka penetrate ani nga course, no, kining chemical reaction engineering. Okay, so chemical reaction engineering is the synthesis of all these factors with the aim of properly designing a chemical reactor. So kinahanglan gyud ka mo base aning tanan. So the word is synthesis. Okay, so kinetics, contacting pattern, and performance equations are the three basic concepts to find what a reactor is able to do. Okay, so kinetics, contacting patterns, and performance equations. So yun na lang mastero na to na kanang tulo, no, so that maingon na to nga maayog ka nga chemical engineer. Tanawon pa lang nimo ang usa ka kanang chemical reaction kabalo na kag unsa gamiton nga reactor diha, no. Okay, So nga nakaka mayong engineer. So we go to now to the basic of reaction kinetics, no. Mura na siya gabalik sa ato ang course, no. First of all, we are going to find the chemical identity, no. A chemical species is said to have reacted when it has lost its chemical identity. So daghan man taog ka ng mga chemical reaction nga type. So there are three ways, no, a chemical species can lose its chemical identity. Okay? Number one is decomposition. Doon natin example diha sa atong right side, which is the ethane, no? Then the breakdown siya, no? Okay, so we have also the combination. We have nitrogen and oxygen gas. Then we have isomerization, meaning to say nag-isomerize siya, no? Daghang process, mayroong isomerization niya sa ato ang this is not C2 H5H6, so that is ethane, no? So nag-isomer siya, depende sa reaction kung pwede po ka mag-add og oxygen, depende na lang, no? But then this is the three things nga ato ang three ways a chemical can be lost its chemical. Actually daghan po, no, lunag oxidation, no, wala gyapon dia because we are dealing on container, no, a vessel, a reactor, no. So if you are going to oxidize something, you are going to burn, no, so dili ka kinahanglan og reactor, no. So kini siya magkinahanglan kag mga reactor ani kay mag-decompose, mag-combine og mag-isomerize, no. Kaya isomerization usually naani siya sa mga biochem or biology nato involved, okay, sa mga organic. So chemical reaction is a process that leads to the transformation of one set of chemical substances to actually human naman tani, no. So tadi lang kay tam discuss ani nga part. Okay, also this one, no, how can we count them, no? Actually we are going to use the moles, no. Grams also importante sa kategorya na. Then we have something which is called molar mass, then Avogadro's number, kabalo na taana, no, for sure, no. Okay, so these are the things we are going to deal, no, grams, moles, molecules, no. Okay, okay, so remember that before reaction kini pinakaubos na tong picture. Okay, so it undergoes reaction and then we have what is called after reaction. Now ang importante din actually when designing a reactor, ang atong reactant mo gini atong tan-awon, no. Unsay ang mahitabo niya, mora niya ato ang speculate, no, nga mao na siya pila percentage nga mahimo siya ingon ana, pila ka buok, no, pila mga 80% ba 90%, depende lang, no. And then you are going to design a reactor for that, no. So ang importante ani niya is the reactant. Okay, so the basic of reaction kinetics. So example this one, we have A forming B, no, A forming B. Okay, so in other words, ang atong reactant diha is A, ang atong product is B. Later on ang atong A mawagtang siya, no, anam siya kawagtang, no, ma-form into B. So wala nang A, B nang nitabo, no. Kung 100% siya nga reacted to form product B. Okay, so actually di pa ni nato ta i-discuss, so sige lang ato lang sa ni kuan, no. So we have negative, that negative atong tawag diha is because it is diminishing man ang ato ang A. Kung atong tanawon is the reactant, pero kung B gani atong tanawon dili na siya negative, positive na siya. Okay, so the reaction rate is the rate at which a species loses its chemical identity per unit volume. Okay, actually mayong tag rate, it involves time, no. In this part ang ato ang reaction is per second, always gina per second, but dili necessary nga ang default niya per second, pero dili necessary per second tong gamiton, na po per minute, per hour, depende lang sa problem nga mo arise, no. Pero ang default dito na niya actually is per second. Okay, So when they say that the reaction rate is the rate at which species loses its chemical quantity per unit volume, it involves also a volume. So that's why nga to ang formula there is 1 over B, no? Then the differential of concentration na siya, no? Concentration sa ato ang A per unit time. So ang nitabuan na niya is so moles I form over volume of fluid per unit time. So kanang moles form ug ang volume of fluid kana siya concentration na per unit time. So CE over time, no? CE. Okay. Will not talk about that kung maglibog pa ta kung sa itong kuano, no? Anyway, napamanta sa fundamental part. So this one is positive because we will be dealing on the B part, no? Kining pikas ang iya ato ang gitanaw, pero kining pikas ang atong gitanaw diha is the B part. Okay? And we are also using mass of solid instead of volume of fluid. Okay? Gamiton lang nato ang density ana niya. Okay? So, okay, here's the deal. Here's the details about that, no? Negative rate of disappearance of A. Naamday dire, no? Kalimot mo ko naamday nga gibutang dia. Okay? So, R is note that this is an intensive measure, not an extensive. Sa atong thermodynamics. Then, the minus sign means disappearance. Okay? So, ang atong unit na niya is mole per cubic per second as a default, no? Okay? Okay, dependent ang ato ang isa function ang ato ang, by the way, ang ato ang rate of reaction, which is RA, is a function of temperature and also concentration. Okay. So, mo na ato ang function niya, no, sa temperature o sa concentration. Okay, but as an example, we have here a constant key, which is the mole per cubic meter, and then the reaction order. We'll talk about that on sana to pagkuha ang order, no? By just looking at the reaction, no? Reaction balance, kabalo na tag kana siya first order, zero order, o second order reaction na siya. Masabtan na nato. Okay, and we have also the activation energy, denoted by letter E. Remember that sa inyong abtan ang activation energy is the energy needed, no? The energy needed for a reaction to take place. Okay? So the higher the activation, and remember that the higher the activation energy, mas lisod ka maka produce og reaction, no? Kaya lang imo sa na siyang paubson. Pagaus ay mo sa na siyang pagamyan ang iyahang value sa atong activation energy. Okay? And it is temperature dependent, no? Okay? Sa ato ang term. So, mo niya pinaka equation niya. Kung yun sana siya pag-derive, we will derive that later on. No? Okay. So, I have here embedded some videos. Duha ni ka video siguro mga about 45 minutes na ni tanan duha, no? 45 ba? Mga 30 minutes na siguro. Okay. About chemical engineering. Then later on, mobalik ta sa to ang reactor, no? Okay, which is part of our discussion. Okay, mo niya ato ang by the way before tayo proceed diha. So this is our course outline. So ang first topic nato is the introduction. We'll talk about the kinetics and chemical reactor engineering humanata. Then later on with after the video mag-talk ta ning diesel og reactors, no? Ug na patay time magkuha na ta ni ato ang mole balance, no? Kini sila, no? General mass balance, mole balance, reaction, stoichiometric table. So mga computation na ni dapat ikan din padulong sa ubos puro lagi na siya mag-compute na ta diyan dapat. Okay? So we'll go back later on this part. Okay, so proceed ta sa ato ang video discussion. This was taken from the YouTube, no? Okay. Wait ha, para makuha na to.
Hi everyone, in this introductory video, I want to talk about what exactly chemical reaction engineering is and talk about why learning this topic is important. Firstly, I just want to preface this by saying that this course is also sometimes known as reaction engineering or reactor engineering. However, all the same material will be covered. Okay, so what exactly does chemical reaction engineering mean? And what will you be learning in this course? Well, as you may have imagined, chemical reactions are certainly going to be involved. And in particular, the chemical reaction engineering course here is related to designing various chemical reactors to create the conditions within a reactor that we want. So, said more formally, chemical reaction engineering is basically the study of reaction kinetics, the rate and direction at which a reaction occurs, and the study of the reactors in which the reactions actually take place. By that I mean, let's say that we want to produce 80 kilograms of some product per hour. What kind of reactor should we use? What temperature should the reactor be at so that it doesn't explode or injure someone? Is there a safer or a cheaper way to synthesize this product? These are just a few of the many questions the engineers who design the reactors must consider. To build on what I previously stated, the primary focus of chemical reaction engineering is the study of the reactor design, such as will a certain exothermic reaction melt our reactor due to the sheer amount of thermal energy generated. Economics are also a huge part, as there is no point in developing a reactor if the process is not funded and or not feasible to the investors or company putting up the money to build it. And how do we scale a process? By this I mean, how do we take a process we developed on a small scale, like a pilot scale, and scale it to be used in an industrial setting? So, now that we have an understanding of what chemical reaction engineering is, why is it important to learn about? Well, if you're watching this video, you're likely an engineering student, an engineering professional, or someone else interested in learning about reactor engineering. But why is it important? Well, learning about the relationship between reactors and chemical reactions is vital to developing processes that are not only safe, but also cost effective. So think heating and cooling costs, and has minimal environmental concerns. So, does our process produce some environmental degrading byproducts? So, in summary, throughout this playlist, we will be going through various types of reactors and how we can size them for certain desired products, through identifying and applying appropriate reactor design equations and methods. There will be lots of interesting topics covered throughout this playlist, and by the end, you should have a strong understanding of chemical reaction engineering basics. Thank you for checking out this video, and I hope it helped your fundamental understanding about what chemical reaction engineering is, and inspires you to continue learning about this topic with us throughout the duration of this playlist. Hi everyone, in this introductory video, I want to talk about what exactly chemical reaction engineering is. Hi everyone, in this
What's up, guys? It's time to start our course in reactor engineering. We are now in block number 1, which is essentially chapter 1 on your book, Fogler's book of, I remember it's basic elements of chemical reaction engineering. And yeah, we're going to see the introduction and the molar balances. We're going to explain, of course, what's a molar balance, how to do it, how to apply it to a reactor, and essentially we're going to find out some equations or design equations for those reactors. So this video, it's essentially section number 1. We're going to see the introduction to reactors. What type of reactors do we have? Some reactor kinetics and the uses of those reactors. Then we're going to see a lot of pictures. I'm going to try to explain you how to recognize or to know what's a reactor in the chemical industry. And in the second video, we're going to jump to molar balances, which are done essentially in batch reactor, continuous stir tank reactor, plug flow reactor, and packed bed reactor. Right now, we're going to see just the introduction to reactors. So the first thing I want to let you know is what's a reactor. A reactor is, I try to look out for many definitions, but I think the most common sense definition is this one. It's an equipment used to carry on a chemical reaction. So essentially, if you have a mixing unit and you're not doing a chemical reaction, that's not a reactor. But if you are carrying on, I don't know, A turns into B, then you are doing a chemical reaction, therefore that's a reactor. And actually, there's also types of pipe. If you're using this pipe just to transport material and you don't know you're transforming A to B, technically speaking, this is a reactor. Of course, we don't want to do that. We want this pipe to transport A into, of course, only A. We don't want transformations. But technically speaking, if you have something, a device or equipment that transforms a chemical reaction, then you have a reactor. So yes, chemical engineers design reactors to maximize net present value for the given reaction. So that's kind of fancy. What does that mean? It means essentially you want to improve the reaction in
Excuse me, sir. Naka-mute ka, sir.
Okay na? Madungog na ba?
Yes, sir.
Ang video na dungog ninyo wala.
Wala, sir.
Ha?
Ganina na dungog, sir.
Nadungog na ninyo. Okay ra, ato lang ipadayon. Okay ra? O mobalik ta. Ha? Ibalik lang nato gamay, no?
Yes, sir.
Ha?
Balik lang gamay, sir.
Sige, sige, okay, okay.
No, it's what's a reactor. A
Karon padungog
reactor is,
gyapon.
I try to look out
Yes.
for many,
Okay,
many definitions,
thank
but
you.
I think the most common sense definition is this one. It's an equipment used to carry on a chemical reaction. So essentially, if you have a mixing unit and you're not doing a chemical reaction, that's not a reactor. But if you are carrying on, I don't know, A turns into B, then you are doing a chemical reaction, therefore that's a reactor. And actually, there's also types of pipe. If you're using this pipe just to transport material and you don't know you're transforming A to B, technically speaking, this is a reactor. Of course, we don't want to do that. We want this pipe to transport A into, of course, only A. We don't want transformations. But technically speaking, if you have something, a device or equipment that transforms a chemical reaction, then you have a reactor. So yes, chemical engineers design reactors to maximize net present value for the given reaction. So that's kind of fancy. What does that mean? It means essentially you want to improve the reaction in order to get more profit. So let's keep doing. How do we do that? The designers, which looks like a fashion design, but no, it's not fashion, it's engineering design or reactor design, ensure that they got the highest efficiency possible towards the desired product. So if you're turning A into B, of course you want to turn all A into B. Sometimes you're not going to be able to do that, so you're going to find out or design a reactor or try to change temperature, pressures, flows, whatever you need to do to improve that conversion rate. And actually, you're going to base all this in money. So, of course, if I tell you I'm going to increase 1% yield, but you're going to need to invest $1 million, well, you need to check out if it's actually worth that 1%. So yeah, that's the highest yield of product. And as I told you before, you need to require the least amount of money to first of all purchase or to invest and to operate, because one thing is having the reactor, the other thing is actually operating. You will need someone there taking care, someone that cleans, someone that operates, control, temperature, heating, cooling, piping, pumping, compression, all those stuff that are behind the operation. So why do we need reactors? Well, we want to convert material. That's what I love chemical engineering. It's about transforming, converting, producing materials which are not that useful, or which maybe they are useful, but you want to turn them into something else. So let's say you have this low volume material, and I love it because you use your knowledge, your brain, and you transform it into more profitable materials. So that's why I love chemical engineering. Let's do some magic with our knowledge and we get more money with that. We do it because we want to have a specific unit for that operation. So at least we know that this tank is where our chemical reaction is taking place. So if you don't have in the, let's imagine this plant, or chemical plant, you have a problem, you're not getting the yield or the conversion you want, you go to the reactor, you study the reactor here, you don't need to check this out or this out, of this piping here. Maybe eventually, if you find out that the reactor is fine, you will need to do that. But the first thing you want to do is to go directly to the reactor. So that's why we are doing this in one reactor and not in many operation units. So yeah, essentially you want a specific point or space where the reaction is being carried. And not only that, you also want the reactor to control the reaction in a safe manner. So if you don't even know where your reaction is taking place, well, that's not that safe. If you know you're taking place in this tank, well, at least you're going to make that tank the most safe place in the plant, or at least that it doesn't explode or leak or whatever stuff or thing may happen that may be hazardous for health or environment or workers, whatever. And the thing here is that it's easy to maximize efficiency. Why? Because then you're going to work fully on this reactor and not in the whole plant. So you can, I don't know, change the volume, change temperature of flows, pressure of flows, concentration, all those process variables that affect the conversion rate or yield, you can change them. So that's kind of cool because you're going to change also levels, temperatures, inlet, all those things that you can change. You're going to do them in this specific unit. So the next thing we're going to see is the types of reactors. And there are many, let's say, types of reactor or how to order them or classify them. So I brought you the most common and the ones you're going to be using. For example, batch, or you can say also is that semi-batch process or a continuous process. This is in general, you have a plant operating all the day, all the year long. You transform A to B, let's say, in this reactor, and you have a flow of 10 kilograms per hour here, and you take out 10 kilograms per hour of B. This is A. It's an example. A batch is essentially just you got this tank, you fill it up, you let time pass, it reacts, and you take it out. A semi-batch is a mixture between a batch and a continuous. That's one form. Another type of reactor classification is either is it catalytic or not catalytic. When it's catalytic, of course, as the name implies, you have a catalysator or catalyst. And when you do not have it, well, it's a non-catalytic reaction. Then homogeneous reactor, which means there are the same phases, let's say liquid-liquid or solid with solids. And then you have the heterogeneous phase. For example, when you have this, let's say you have a gas here, and this is like a packaging unit. This is solid. So they react or they do a process here and they interact between solid and gas, which is a heterogeneous reaction. And yeah, you take out these here out. So that's also important. And the most, I think the most important thing to know is these categories, which is the reactors we're going to be studying in this course, this introduction to chemical engineering reactors. So the batch reactor is the most classic and obvious one. Then comes the semi-continuous reactor, which I told you is a part batch and part continuous. Then we go to a continuous stirred tank reactor, which is the most, I think, basic and easy to model one. You have a tank, and as the name says, it's continuous. So you have this flow, and you mix, and react and take out the product. So as you can see, it's a tank which is stirred continuously and it makes reactions. Then comes the plug flow reactor, which is essentially some pipelines here. You are reacting the material in the pipes, so you got A and it starts reacting all over here and you get out B. And then the packed bed reactor, which I told you this little example. You have this reactor, you got this packed bed here, and you are reacting, I don't know, gas with this solid, and you take out the product. So those are the type of reactors, please. This is kind of theoretical. I know it because I've done too much of that. I actually didn't like memorize it. You don't need to memorize it. You're going to be working with them and you're going to see the characteristic of each of them. For example, continuous are in steady state. Heterogeneous normally implies a packet bed here. Batch reactor means that they're time dependent, and with the time you're going to recognize each of these concepts. And now I brought you some pictures. I want you to realize what's a reactor. Look, this tank, you can see this is like the over part, and this will be the whole tank. This is an inlet maybe, and this is the outlet here, or maybe this is the inlet and this is a level. Then you got this part here, which is the where the agitation unit goes. So you have this unit here, it goes all the way down. Of course, this should be 90 degrees. This is, let's say, lying down. So you need to stand this tank up and you will have this your agitation unit here and you're going to mix it. And this, as you can see, is a tank and you have this the steering system here. So as you can see, it's a continuous stir tank reactor because you have the inlet here and maybe outlet. I don't see the outlet, but it should be there. And this is the manhole. What's a manhole? Is essentially a place in which a man can go in and you clean it, or you can check if there's something stuck or something like that. Then we have still a CSTR, or a continuous stir tank reactor. You can see here is the thing we were talking about, and this is the steering unit. But we got this now, a jacket system. What's a jacket system? We're going to see that later, but essentially it's just a lot of tubes that are heating this reactor. You can see you have many inlets here, made for levels, temperature sensors, and the mouth. Now we are in a plug flow reactor. As I told you before, it's essentially just pipelines. They go here, go here, and as they move, they are reacting the materials. So eventually, if you were having A plus B here, and your reaction is something like this, well, you're taking out C out here. The same here. Now we have a different arrangement and you actually cover this, so maybe it's more like static. Maybe you're selling the reactors, you want to do it as static as possible. But actually in the chemical industry, you're not looking that into aesthetics. You are more into usefulness, efficiency, and that. And makes sense because if I were an engineer, I wouldn't care it is not fashion at all, but if it works, it turns my material A into B, and I can sell B way much expensive. I will not care about the fashion elements. And then we have a packed bed reactor. It's essentially the same tank. This is the diagram. Because if I give you the photo, you will not be able to see the packagings, of course, because this will be cover of all metal walls. You have the reactants, you take them here, maybe this is gas. And this is a catalyst. You have the catalyst on this bed or this solid part, so they react, they make their reactions and you take out the products. It's not that difficult or complex as it seems. It's so easy. Then, yeah, still we're talking about packed bed reactors. As I told you before, you can see there's nothing. It's only metal. You're gonna see the packed bed. So you could have different arrangements of pellets. Pellets are these balls or these catalyst. This contains the catalyst. So you could either have a sleek or slim here, or you can have a wider. You have many small pellets or big pellets. And obviously it depends on what are your requirements on pressure drop. You want to increase conversion, to increase the surface area. There are many things that you might want to consider. It's not just about, okay, just pull them up here. So we're now in this subcategory, which are the lab reactors or reactors that are done on lab scale. You can see they are simply, you've been in a chemical or a chemistry lab, you can recognize this is like a small beaker. You have all the support. You got this little condenser, which has nothing to do with the industrial condenser. And yeah, you have all this electric control device. You got this constant pressure funnel, all these discharge level. Of course, you have an inlet. And as you can see, this is done to improve the reaction. So if you can improve them in the lab, you can improve them maybe at the larger scale. So the same here. Normally you use chemistry workers or chemists or even also chemical engineers to improve the reaction. The thing here is that you want to improve the yield, or maybe you want to lower a temperature or heat requirements or viscosity, so you get lower pumping cost. All these things that might interest you are here. And normally you also want to model that. So if you can model the lab one or the lab experiment, you can see how, I don't know, many transfer materials, maybe this is momentum transport, this can be a heat and heat transfer, or not this. Actually, let's say this is a heat or temperature profiles. These are momentum or velocity profiles. You can see all the agitation here. And maybe this is the mass profile, how they're changing this. Let's say the blue one is A and the red one is B. And A is turning into B. So you can see how at the beginning you have a lot of A and at the end you have a lot of B, which makes sense because you are transforming A into B. So that's why you can also get some lab reactors. You want to improve and model and eventually just get a better version of your real reactor in the chemical industry. So same thing here. You can recognize them. Maybe this is a CSTR, small scale, and this is a PBR, of course. You have this packed bed. As you can see, you have a lot of pellets, so I am guessing these are a packed bed in which you get here the gas and you take the out. So yeah, same thing here. You have, actually this is also a packed bed reactor, but you cannot see the packaging only here, but you need to be watching closely. And yeah, essentially that's lab reactors. We're going to see a new trend, which is micro reactors. Essentially, as the name says, micro 10 to the minus 6 meters. So why do we use this? Because we get many, at the micro scale, we get many good things. You can control better. Essentially, it's all about transport phenomena. Hopefully you've seen that before, because you're going to get that you get laminar flow and you get more pressure control and heat controls and all that stuff. And yeah, you can see another here. You get a better control of the reactants. And the thing here is, once you got this microreactor working as you wish, you can get, I don't know, maybe 10 to the 6 units, which is about 1 million, or maybe you just want 1,000, and depending on the flow, of course, and your requirements. But you can get this very scale up abilities. So the same thing here. This, instead of using piping, you got these hoses, small hoses here. Instead of getting huge pumps, you got small pumps. And yeah, that's the microreactor trend. Now, just to let you know about thermal insulation, you've seen this in heat energy or mass balance, maybe heat transport operations, whatever. But I'm going to explain you once again, just to let you know. So these spots right here, this is with the thermal camera. All these, as you can see, if it's yellow, it's hot, or let's say it's a high temperature, and if it's black, it's low temperature. So what you want to do is low temperatures, because the ambient temperature will be around 25 Celsius, or I think 70 Fahrenheit, about like that. So you don't want high temperature, because high temperatures implies there's a difference in temperature, and difference in temperature means that you're going to lose heat with the ambient temperature or the ambient air. So you don't want that. You want to avoid all these little points here. And how do you do that? You do it by isolating or thermally isolating the reactor. So look at this. Instead of losing all the heat, you just cover the reactor, cover the inlets or all the piping, and you get this kind of arrangement. So look at this. You have all these pipes are covered. This is not metal, this is isolating material. And you also cover the heating vessel. What type of material use? They use a lot, but this is how they look. It's like a foam-like or like an asbestos-like. You also use, you cover it with aluminum, and yeah, essentially that's the thermal isolation. One thing I want you to let you know is, let me go to the next picture. I remember going to my first chemical industry, and I thought these were pipes. And I wasn't that bad, because there are actually pipes inside of it, but I thought these were the whole pipes. And that's not true, actually. You got this isolation inside this metal. So you see the pipe here. It's actually covering the isolation material. So maybe the actual size of this pipe will be, I don't know, this size. So even though you see a huge pipe or a huge tube here, you got this small tube here because it's super hot, and you got around it all this material. So that's about thermal isolation, just a overview, so you can know, like, there's isolating problems in reactors. So if you want to keep a temperature, for example, you want to be at the same temperature isothermical, you will need to take care about that. Or if simply you don't want to spend that much money in heat requirement, you will need to buy some isolation material. And that's everything for this this section number 1. Let me tell you what we've seen so far. We saw a small introduction to reactors, type of reactors, reactor kinetics, the uses of these reactors, and well, this is I just move it to here. What's left is section 2, molar balances of batch reactor, continuous stir tank reactors, plug flow reactors, packed bed reactors. We're going to see now the mathematics, and we're going to derive an equation that help us to model these 4 reactors. So thank you for watching, guys. If you are interested in how we can model these tanks or these reactors, please just go to the next video. What's up, guys? What's up, guys? It's time to start our...
Okay. So, ang atong molar balances sa atong every reactor, maybe that will be by Friday or Thursday na, no? We are going to finish all the reactors, no? Those what has being discussed by the video is just the synopsis, no? So, we'll go on to the reactor, okay? So, reactor is the heart of chemical process. No? A vessel designed to contain chemical reactions is called a reactor. Okay. An industrial reactor is a complex chemical device in which heat transfer, mass transfer, excuse me, diffusion and friction may occur along with the provisions of safety and control. So you have a very good reactor kung ma-meet nato ning tanan, no? Kining resulting nga rin, no? Okay? So the basic principle is that all chemical processes are centered in a chemical reactor. The design of a chemical reactor is the most important factor in determining the overall process economics. Okay? So just bear in mind that you are called a chemical engineer because of these things, no? You know how to make a chemical reactor. You know how to design, no? Not only designing by the name that you design, but you design it for the purpose that you profit for it. You can you can make something that is not useful into useful, and also it is safe. It is a safe reactor. Okay. So the basic design for reactor is this one, no? Morning kinahanglan nato. The need for a reaction type. So nasulti na to niya, actually there are only 4, no? 5 yang gingon nag-include niya ang semi-batch types, no? Actually ang formula mo gud niya pareho ra sa mamaora sa kuan, no? Sa batch type. Okay. So we have the reaction type, the removal or addition of heat, the need for catalyst, katong catalytic reactor, the phases involved, the mode of temperature and pressure control, production capacity or flow, residence times. Residence time gani amo nang time niya nga gihatag nato nga mo react siya for a certain product that we want, no? Kung pila ka percentage, 100% ba, depende na lang sa to ang need, no? 80% ba, 90% ang ato ang product nga kinahanglanon. Okay? Then the contact or mixing between the reactants. So kini nga mga basic need na to for the designing of a reactor. Actually this is only the basic, no? There are many things to consider pa ang yung thermodynamics niya, no? Kinahanglan nato na, no? Okay. So the reaction types, we already know this one to sa ato ang general chemistry. We have what is called the direct combination or synthesis reaction, which is A plus B is equals to AB, no? Direct combination or synthesis reaction. Then the chemical decomposition or analysis reaction, reactant nato is AB, and then it decomposes into A and B. We are talking about this reaction type because this is our basis, no? Usa sa atong basis pag design nato og reactor, okay? Then we have what is called single displacement or substitution reaction. So we have an element A and then a compound of BC. Then by single displacement or substitution, A combined with C and then B. Okay. Then metathesis or double displacement reaction, AB plus CD reactant equals CB plus ED. Wala na ED diya, no? Siguro ang atong importante din nga part is the CB only. Ang ED is not important. Okay. In addition to the basic data includes mga thermodynamics ng mga part na a heat and mass transfer characteristics, physical, chemical, and thermodynamic properties of components taking part in the reaction, corrosion, aeration, characteristics of any potential hazard associated with reaction system, and the reaction rate. Okay, very important ang reaction rate. Unsa siya kakusog, unsa siya kahinay, no? Basig usa ka tuig na pagka maka-produce wa na bati ng imong reactor, okay? Then we have to consider also the endothermic or exothermic reactions. Okay? So within heating describes a process or reaction that absorbs energy in the form of heat, release energy in the form of heat, light, or sound. Then we are going to solve also for the enthalpy and the change in enthalpy and the change in entropy. Okay? So one thing very important, no, ato lang shortcut. Importante nga wala tay as much as possible i-avoid na to ang exothermic reaction, no. You will understand that later ngano gid ka, no. Okay? Now reaction rate, na speed at which a chemical reaction proceeds in terms of amount of product form or amount of reactant consumed per unit time. Okay? So you have to remember these things, no. Importante ni siya mao ni nga to ang gistudihan before, no, regarding the kinetics, no. Speed at which a chemical reaction proceeds in terms of amount of product form or amount of reactant consumed per unit time. Kay mao man ni siya ang ato ang basis jud, pinaka basis nga nganong kana nga reactor atong gamiton, nganong batch type man, nganong CSTR man, nganong PBR man atong gamit. Depende na lang, no. Kini may pinakakuan niya, kining reaction rate. Okay? Factors influencing reaction rate, these are the things, no? Concentration, the nature of reaction, temperature, pressure. Ang kining catalyst, option lang ni siya, no? So pinaka buod niya, ang pinaka kuan niya is concentration, the nature of reaction, temperature, and pressure. Catalyst, gamiton lang na nato siya kung dili yun siya mo suffice ang ato ang production sa ato ang need, no. Kinahanglan ta og catalyst. Remember that mo gamit ang catalyst, that is money, no, mo gasto na sad ta. Okay, so as much as possible atong i-avoid siya. Okay, kung kaya na to nga makaproduce og reaction without using a catalyst, so be it, no. Okay. So these are the modeling in principle. So mao ni ato ang when we design, no, in design to mao gyud nato ang gamiton nga principles. Inputs, okay, inputs plus sources equals output plus sink plus accumulations. Ang pinaka-importante din ng dapita ang kanang gitawag nga accumulations. Okay? Kay kana accumulations nag-accumulate na siya within the reaction. Mo na yung maglibog kag asa kan dapitan na siya, no. Remember nga ang balance sa ato ang tanan diha, in is equals out man. Pero unsa na to pag kuan accumulation? So we will understand that later, no. Okay? So output plus sink plus accumulation. So doon na lang ta input, doon na lang ta sources, then yan lang atong output plus sink plus accumulation, mag-match lang duha, no. Okay. So, basic reactor element. By the way, balik na to tong kuan. Kining modeling principles. Mura na siya stoichiometry, no? Ato ang balanse sa ato ang mga yugas, mga na murag mao pero kini siya doon na lay accumulation. Okay? Mura na diha. Okay? Now, basic reactor element. Ang need na to is material balances. Master man ni nato, no, di ba? Heat transfer and mass transfer, master na po nato ni during our thermodynamics lecture, no? Okay? So, importante kayo na siya, mo na basic reactor element. Okay? So, in other words, you are going to master all those things, katong mga mass transport phenomena, katong mga mass transfer, mga heat balances, katong mga thermodynamics, mole balances, kinahanglan mo master sa gito nato, no? Before ta mo design gyud yung ani kay di ganito mo master basta lisura gyud nato i-solving ko ano kining chemical reaction engineering og mag-design ta og certain reactor, no? Need yun nato ang mga heat transfer ug mass transfer. Then material balances is also called mass balance, no? Mass in is equals to mass out na siya. So, conservation of mass, no? It's an application of conservation of mass to the analysis of physical system. The mass that enters a system must, by conservation of mass, either leave the system or accumulate within the system. Okay? It is impossible nga ato ang mass mulabaw pa sa ato ang atong output mulabaw pa sa ato ang input. Okay? So, kanang ato accumulation, it means to say nga na nag-accumulate, something has lost. Doon ay nawa po, no? Okay? So, mathematically, the mass balance for a system without a chemical reaction is as follows. Input is equals to output plus accumulation. Wala na chemical reaction. How about kung doon ay chemical reaction? Okay. Kung doon ay chemical reaction, mag-involve na siya og thermodynamics. Doon naman tayo heat, no? Okay? Mag-involve na siya. Kung pwede tanga ito mo base sa ito ang pagkuha sa ito ang maning heat, aning maning mass, aning uban, no? Okay? Now, is the phrase commonly used in engineering of physical processes that involve molecular and convective transport of atoms and molecules within physical system. Now, transfer of mass from high concentration to low concentration. When we deal with mass transfer, ayaw jud kalimti ang ato ang conservation of mass. Adto gyud ta mo sang pirmi gyud ta mo sang to dili gyud na siya pwede nga ang in nato lahi ra sa atong out. Okay? Kinahanglan gyud na sila magkaparehas. Okay? Kung dunay error pangitaon jud nato ay dapita atong error ani. Something wrong with my computation. Now gyud nato siya. Okay? Okay, heat transfer is the transition of thermal energy from a heated item to a colder item. So, transfer of thermal energy. Likewise, maupod sa ato ang energy. Energy cannot be created nor destroyed. It can, however, it can only be transferred from one form to another. Pareho-pareho ra gyud sila sa energy. Kung ato na siyang hunanang filming, nga mao gina siya, di kita mawa inig balance nato, no? Kinahanglan na agin sa tong nahuna. Okay? The modes of heat transfer kinahanglan nato niya is jacket, no? Jacket meaning to say kanang insulation, no? Then internal coils katong magdag heat, no? Then the external heat exchanger. So we have cold water niya ato siyang pabugnawon pinaadili na jacket gamit nato kun dili heat exchanger, no? Then we have cooling by vapor phase condensation. Okay? So when we said vapor phase condensation, you are going to change the pressure, no? Aron doon na kay vapor phase condensation. Then, so sa pag-heat pod, we have fired heater. So internal coils heat, then heater, fired heater is heat, external heat exchanger is cooling, jacket is cooling, vapor phase condensation is cooling. Okay, so we have the basis for our reactor design, no? Okay, so reactors ang atong design niya upat kabuk ang atong basis, mode of operation, induced base classification, the phase base classification and the catalyst base, no. Mode of operation gani kung design tag reactor niya atong gamiton sa ato ang pag-design is the mode of operation. So mangutan na tag unsa nga type nga reactor na, is a batch type, it is a continuous type or a semi batch. Kung atong basihan po is the end use base classification, so it is a polymerization reactors, a biological reactors, or electrochemical reactors, depende, no? Okay? Or absorption reactors or extraction reactors, no? Depende lang sa kuan. Sa ato ang end use base classification. We can also do the phases based reaction, no? Phases based classification, I mean. So, is it a single phase or a multi-phase? This is sa na siguro na agi na siguro ninyo ang ato ang liquid extraction, no? And also the last basis for the reactor choice is the catalyst base, no? It is a homogeneous or heterogeneous, no? Kung kining catalyst base siyempre maggamit ta og catalyst, no? Catalytic, okay? So the reactor types, they can be classified according to the mode of operation, induced application, number of phases, and a catalyst is used, whether it is homogeneous or heterogeneous. Okay, so mao ni ang reactor type, mag-ano siya mag-basis na to kung unsang klase sa reactor atong gamiton. Classification of mode, ito na ning ko ano, gibalik na siya. So sa mode of operation, we'll have the batch reactors, the continuous reactors, and the semi-batch reactors. Okay? Ang batch reactors, katurag yung siyang mura kag nagluto og kanon, no, nga magbugas tang tubig niya, pagkahuman dungagon, no, then huwat ka maluto, pagkaluto habaon, nga na siya mura siya batch, nga na siyang pagya, no. Then ang continuous reactors, kuan siya, no, kanang doon na siya in, and doon na po out nya, kanon mura siya tubig nga gibutangan nato, gibutang tag tubig sa usa ka tangke nga dunay buslot, no, sige tagbutang tubig sige po siya gawas, ingon na siya, no. Ang semi-batch type reactors doon na kay residence times, no, imo pa siya mura siya pareho ka galuto ka ng sudan, sudan, and then pagkahuman pagkaluto na ibalhin og lain nga sudan yan, luto na pag lain, ibalhin na pud nimo lain. Pero continuous, semi lang siya, semi kay dili man siya pwede na to yung tawag siya continuous, kaya continuous permanente yang in, permanente ang gawas. Pero ang semi-batch types, more na kay residence times nga imong gamiton, no? Then imo siyang igawas pagkahuman butang na po kaglain, no? Mura-mura siya batch reactors. Okay? Mas dugay lang batch reactors because you are going to do that. Mura gid siya og kanang pagkahuman nimo lutuan niya, magprepare na pod kaglaing materials unsa din na. Ang semi-batch dili na, ditso na lang siya, pero dili pod siya mahimong continuous. Okay? A batch reactor of reactant is introduced into the reactor or operated at the desired conditions until the target conversion is reached. Batch reactors are typically tanks in which stirring of the reactants is achieved using internal impellers, gas bubbles, or a pump around loop, where a fraction of the reactant is removed and externally recirculated back to the reactor. Okay. So temperature is regulated via internal cooling surfaces such as coils or tubes, jackets or reflux condensers or pump around loop that passes through an exchanger. So gi-control ang temperature, gi-control tanan, no. So lutuon sa gid siya, no. React siya tanan diha dapita, no, with these parameters, no. Now batch processes are suited to small production rates, too long reaction times to achieve desired activity, and for flexibility in campaigning different products. So dugay gid siya, no. Dugay siya na to kuanon. So that's why tawag siya batch reactor. Mao ni yang itsura sa batch reactor, doon natay stirrer, Doon na tayo vent system. We have products overflow from the reactors. Overflow ra na siya, dili na siya nga to ang kuano. Panalitan sige tag butang sa atong reactant 1 o reactant 2. Kung nahuman na siya og kuan, na-react na siya tanan certain time, dugay mo siya to ikuan. Then add na pod kag reactant 1, reactant 2. And we have our products overflow. Muna na no, habwa no. Okay. Application niya is fermentation of beverage products, wastewater treatment. Kasagaran ani makita nako kining fermentation no. So kining wastewater treatment. Okay? Siguro nakasuroy naman mo mga industry siguro. Nakita na gyud ninyo ni no, labi na ning wastewater treatment. Dugay kayo ang iyang pagkuano, pagkugulit sa to ang mga waste no. Una na to malimpyo ang tubig. So that is application of batch reactor. Then continuous reactors. So reactants are added and products removed continuously at a constant mass flow rate. So doon na siya constant mass flow rate. Dili ingon na to siya magpaabot ta og kuan time nga mahuman siya react no, dili. Doon na siya continuous ang iyang kuan, continuous ang iyang daga no sa iyang mass flow rate. Okay? So large daily production rates are mostly conducted in continuous equipment. So usually ang ato dihang production is not 100% ang iyang desired product. So certain percentage lang atong need. Okay? So these are the reactors that can be called as continuous. The CSTR, of course, the pug flow reactor, and the tubular flow reactor. A continuous stirred tank reactor, or CSTR, is a vessel to which reactants are added and products removed while the contents within the vessel are vigorously stirred using internal agitation or by internally or externally recycling the contents. Now, CSTRs may be employed in a series or in parallel. Okay. Now, residence time. Average amount of time, a discrete quantity of reagents spent inside the tank. This is the residence time. No? Unsay pag-compute na ito. Volumetric flow rate divided by volume of the tank. So that is the residence time. Volumetric flow rate divided by volume of the tank. Okay. At steady state, the flow rate must be equal the mass flow rate out. At steady state, meaning to say, pareho imong in, pareho imong out niya, walay diferensya sa imong volume sa imong tank. Permanente lang siyang mao nga level. Okay. Now, CSTR applications. Continuous stirred tank reactors, or CSTR, are most commonly used in industrial processing, primarily in homogeneous liquid phase flow reactions, where constant agitation is required. They may be used by themselves in series or in a battery. Okay. Now, fermenters are CSTRs used in biological processes in many industries such as brewing, antibiotics, waste treatment. In fermenters, large molecules are broken down into smaller molecules, no? With alcohol produced as byproducts. So, catabolic process yan, no? Advantages or disadvantages of CSTR. Good temperature control is easily maintained, kay continuous man siya. Then cheap to construct, mura mo gud siya pipe, no? Nga na lang siya. Dunay pipe niya, dunay bugdong dako kayo, murag tangke. Maora dali na kay ka ng agitator, human ang imuhang design sa imong kuan reactor, no? Okay. Reactor has large heat capacity. Okay? Na interior of reactor is easily assessed, no? Disadvantages is that conversion of reactant to product per volume reactor is small compared to other flow reactors. So that's why dili siya 100%, no? Dili ka maka-reach og 100% kay syempre continuous man gud ang iyang kuha niya, dili pa kay siya maluto, no? Diretso na yung gawas. Okay. So, pag flow reactor. Now, in a pag flow reactor or tubular, mura siyang pipe, liko-liko, reactors consist of a hollow pipe or tube through which reactants flow. Pictured below, mandiha, no, is a pag flow reactor in the form of a tube wrapped around an acrylic mold which is encased in a tank. So, gipakita naman gini sa itong previous video, no? Katong murag pipe bang liko-liko lang. Now, water at a controlled temperature is circulated through the tank to maintain constant reactant temperature. Pwede na to siya patuyukan og laing gagmayng pipe nga doon na siya cold water para makontrol na to yung temperature. Okay? So, again, pag flow reactor, reagents may be introduced into the reactor's inlet. All calculation performed with PFRs assume no upstreams or downstream mixing. Okay, so ditso-ditso lang sila, no? Has a higher efficiency than CSTR at the same value. Okay. Taas mong good siya, good. Taas siya og kanang agia, no? Mo nakamix siya og mas maayo kumpara sa CSTR. This is schematic diagram of pag flow reactor, no? During our derivation of the formula, magkuha na tag gamay, ano niya, parehaan no? dx. Okay? So, ato lang na siyang kuha ano gamay. So, at that dx, doon na tayo accumulation. Accumulation mo nang ato ang formation sa ato ang product, no? Accumulation pila, no? So, magbase ang ato ang accumulation sa ato ang reaction, rate of reaction. So, we'll talk about that, no? Pag-abot na nato sa anang part, no? Okay? Now, application of pag flow reactor. Asa man ito na ma-apply, no? Pag flow reactors have a wide variety of application in either gas or liquid phase system. Common industrial uses of tubular reactors are in gasoline production, oil cracking, synthesis of ammonia from its elements, and the oxidation of sulfur dioxide to sulfur dioxide. Tubular flow reactor is a tube or pipe through which reactants flow and are converted to product. The tubular pipe reactor may have varying diameter along the flow path. So, not necessarily nga pareho ra gid siya og diameter, no? Pwede siya mag-utro-utro. Now, in such a reactor, there is a continuous gradient in contrast to the steep gradient characteristic of CSTR or in series battery of concentration in the direction of flow. Now, several tubular reactors in series or in parallel may also be used. Both horizontal and vertical orientation are common. Okay? So, pwede tag natin kasagaran yun sa ato ang tubular, horizontal, no? Not vertical type. Okay? Chemical reactions takes place in a stream of gas that carries reactants from the inlet to the outlet. The catalysts are in tubes. Uniform loading is ensured by using special equipment that charges the same amount of catalyst to its tube at a definite rate. Okay, the semi-batch reactor. Some of the reactants are loaded into the reactor, and then the rest of the reactants are fed gradually. Alternatively, one reactant is loaded into the reactor, and the other reactant is fed continuously. Okay? So, nga na ang iyang pag-design, no? Okay. So, once the reactor is full, it may be operated in a batch mode to complete the reaction. Now, semi-batch reactors are especially favored when there are large heat effects and heat transfer capability is limited. Exothermic reactions may be slowed down and endothermic reactions controlled by limiting reactant concentration. Okay. In bioreactors, the reactant concentration may be limited to minimize toxicity. Other situations that may call for semi-batch reactors include control of undesirable byproducts, or when one of the reactants is a gas of limited solubility that is fed continuously at the dissolution rate. Classification by end use. Okay. So chemical reactors are typically used for the synthesis of chemical intermediates for a variety of specialty like agriculture or pharmaceutical, no? Or commonly or commodity such as raw materials for polymers application. Okay. Still on in use, polymerization reactors, bioreactors, no? Electrochemical reactors. Balik kanina to, no? Now, polymerization reactors convert raw materials to polymers having a specific molecular weight and functionality. The difference between polymerization and chemical reactor is artificially based on the size of the molecule produced. Remember that polymerization kana siya dako na siya, no, long chains of molecules na siya, monomers into polymers, no. Okay. Now bioreactors. Bioreactors utilize, often genetically manipulated, utilize organisms to catalyze biotransformations either aerobically in the presence of air or anaerobically or anaerobic, no, without air present. Now, electrochemical reactors. Electrochemical reactors use electricity to drive desired reactions. So, muna gitawag lagi electrochemical reactors. Mogamit man og electrochemicals, no? Na examples include synthesis of sodium metal from sodium chloride and aluminum from bauxite ore. Okay. So, electrolysis ni, no? Then a variety of reactor types are employed for specialty material synthesis application, like for example, electronics, no, defense, and others, no. Okay. Muna na yung last nato sa ko, ano, classification by phase. Not pala ito catalytic, no. Now, despite the generic classification by operating mode, reactors are designed to accommodate the reactant phases and provide optimal condition for reaction. Now, reactants may be fluid, solid, and as such, several reactor types have been developed. Now, single-phase reactors are typically gas, no? Kasagaran sa mga single-phase reactors, gas gina siya or plasma, no, or liquid phase reactors. Now, two-phase reactors may be gas liquid, liquid liquid, gas solid or liquid solid reactors. Okay? Multi-phase reactors typically have more than two phases present. The most common type of multi-phase reactor is a gas liquid solid reactor. However, liquid liquid solid reactors are also used. The classification by phases will be used to develop the contents of the section. In addition, a reactor may perform a functions other than reaction alone. Multifunctional reactors may provide both reaction and mass transfer. Example, reactive distillation, reactive crystallization, reactive membranes, or reaction and heat transfer. Now, this coupling of functions within the reactor inevitably leads to additional operating constraints on one or the other function. Multifunctional reactors are often discussed in the context of process intensification. The primary driver for multifunctional reactor is functional synergy and equipment cost savings. Okay. Okay, so those are for the reactors. Then we will go to the vessels. No, doon ay diferensya sa vessels and reactors. Okay, so actually guys, these are already the fundamentals pa, no. If you can see, parts ato ang discussion is reactors and vessels. Gi-emphasize gyud, no, sa ato ang kuan nga kinahanglan i-discuss nato ang kining reactors o vessels because mao man atong i-design, no, reactors. Okay, so I will not discuss first the catalyst ato sa ning i-bypass atong catalysis, and that will be on the third, no, sa katulo pa siguro ni atong catalysis, third week. So we'll go back to the vessels, no. Okay, so vessels are, so unya atong reactor human tatong reactor, no. Vessels are integral to the completion of products and services associated with the process unit. Materials are processed, treated, or stored within many different types of vessels. Vessels enable the process industries to create and store large amounts of products for sale and distribution. Okay, so vessels such as tanks, towers, reactors, drums, dryers, filters, cylinders, hopper, bins, and other similar containers are used to process or store materials. So, difference din nila is ang vessels, it can be a source for reaction, but mostly for storage, no? For storage siya gamiton, okay? Vessels vary greatly in design, no? Like size and shape, based on the requirement of the process. Factors that affect vessels design may include pressure requirements, types of products contained in the vessel, such as liquid, gas, or solid, the temperature requirement, the corrosion factors, and the volume, no? Okay. Reactors, uh, in contrast man no, sa vessel. Reactors are specialized vessels that are used to contain a controlled chemical reaction, no? Changing raw materials into finished products. Reaction variables include temperature, sa discuss na to, pressure, time, concentration, surface area, and other factors. Likewise, vessels, also reactor designs, vary widely based on the chemical reaction that must occur in the process. Okay? So for example, nag-store kag materials pero kabalo kang for a certain period of time dunay mahitabo niya, no? So there's a change, no? But vessel siya, not reactor. Okay? The process technician must recognize and understand vessel components, including floating roof, articulated drain, blanketing, foam chamber, sump, mixer, gauge huts, manway, vapor recovery system, vortex breaker, baffle, wear, boot, mist eliminator, and vein separator. So ato ning discuss usa-usa no kining ang tag process technicians, dili siya engineer, no? Mura siya chemical technician ning una nakabalo na siya kung say mo na yung part niya, no? The engineers designs, no? Okay. Now some vessels have a containment system built around them for personal and environmental safety in case of leaks, spills, or other accidents. So containment system, pasabot na containment. So a containment system usually made from earth or concrete can take the form of a dike, firewall, or containment wall. Okay? Now, process technician must always remember to look, listen, feel, and smell when monitoring and maintaining vessels. No? Okay, not only he is going to use an equipment such as temperature gauge, pressure gauge, like that, no? They also must be aware of the hazard of improper operations of vessels in order to protect people, the environment, and equipment. Now, process technicians, so para bantay, need to be familiar with the symbol that represent different types of tanks, drums, vessels, and reactors, and be able to accurately locate vessels on a piping and instrumentation diagram, P and ID, no? So, actually, we are doing to differentiate the vessels to the reactor. So, kung ikaw ang process technician, sometimes mga chemical engineer, mahimos jud siya nga process na depende na lang no kung sa availability nga trabaho, no? Okay? Kung wala gyud available nga trabaho, why not, no? Anyway, it boils down to money, no? Kinahanglan taog ka ng kwarta, okay? So, kinahanglan katiguta, no? Tanaw, no? Nga kini siya business ni. Kini reactor ni ana katiguta mo tanaw. So, ato na ya pero discuss din ni dapita, no? Okay? So the objective of these things, this comes from the book of Fagler. I think Fagler, no? Now, upon completion of this chapter, you will be able to describe the purpose or function of vessels, such as tanks, drums, cylinders, so ato na nang discuss in the process industries, no? Now, also explain the relationship of pressure to the vessel shape and wall. You may be able to define and provide examples of the following components as they relate to vessels, such as the discant, floating roof, unsa ng floating roof, articulated drain, blanketing, spherical tank, foam chamber, vortex breaker, baffle, weir, boot, mist eliminator, vane separator, sump, no, mixer or agitator, gauge huts, manway, heat tracing system, and before recovery system. Actually, ako na lang gibutang din ang mga definitions aron dili mo masaag na, no. We will be able to describe also the purpose of dikes, firewalls, containment walls around the vessels, no. We will be able to identify and describe the various types of reactors and their purpose, which is humanatani, ato na siya natik just a while ago. Then identify possible hazard associated with vessels, including the following: improper valve line up, loss of nitrogen flow, cross contamination, failure of vent systems, leak or spills, chemical reactions, no? Then you will be able to describe the monitoring and maintenance activities associated with the vessel operations. So, engineers not only design reactors, mo design po taog vessels, no? Sa tanang vessels, storage na siya, mura siya storage, no? But for some reasons, doon na reaction nga mo occur pod, no? That's why dangerous pod siya. Okay? So, these are the key terms. Ako na lang gibutang din he. I think you are going, di lang nato ni siguro i-discuss usa-usa, no? Ato na lang siyang basahon, no? Okay, so articulated drain, a hinge drain, no? Articulated drain is a hinge drain attached to the roof of an external floating roof tank that moves up and down as the roof and the fluid levels rise and fall. So, kining floating roof, actually ang yang pressure ana niya is the atmospheric pressure, no? Dili siya pressurized kay mag-move man siya, no? Mag-move siya depende sa panalitan og mataas ang pressure sa tangke, sa storage tank o sa vessel, saka siya, no? Saka siya. Okay, so doon na may contradicting force po ang atong atmosphere. So later on, maubos sa pod siya, idot po siya sa atong atmospheric pressure, so maubos sa pod siya. Okay? So, moves up and down as the roof and the fluid levels rise and fall. Okay? Now, atmospheric tank, an enclosed vessel that operates at atmospheric pressure, usually cylindrical in space, cylindrical in shape, equipped with either fixed or floating roof, and containing non-toxic before liquids. Okay? Actually, ang floating roof actually is sealed po ni siya actually, no? Sealed. Naka-sealed din sila, no? Now, baffle. It is a metal plate placed inside a tank or other vessel that is used to alter the flow of chemicals or facilitate mixing. Kasagaran ng baffles na makita sa heat exchanger, no? Doon na yung mga baffles diha, no? Nga aron ang dagan sa liquid or unsa diha hot air baron unsa diha dili siya diretso kun dili magliko-liko pa siya, so butangan siya og baffles. Okay? Now, batch reaction, a carefully measured and controlled process in which raw materials, which is the reactants, are added together to create a reaction that makes a single quantity of the final product. Okay? So, bin or hopper, no? A vessel that typically holds dry solids. So, Tawagon siya bin, kasagaran bin. Hopper, murag kung tanaw ni ang hopper murag gamay-gamay, no? Ang bin mo dako, no? Okay. Now, blanketing, the process of putting an inert gas, usually nitrogen, into the vapor space above the liquid in a tank to prevent air leakage into the tank. So, mo na murag, from the word itself, blanketing, habol, no? Habulan, no? Habulan siya og inert gas. Okay. Now, boot, a section in the lowest area of a process drum where water or other liquid is collected and removed. Okay. Containment wall, an earthen berm or constructed wall used to protect the environment and people against tank failures, fires, runoff, and spills. Also called a band wall, banding, dike, or firewall. So, monitor na to containment wall. Then we have also what is called continuous reaction, no? A chemical process in which raw materials are continuously being feed in and products are continuously being formed and removed from reactor vessels. Then we have cylinder, a vessel that can hold extremely volatile or high pressure materials. Then desiccant, a specialized substance contained in a dryer that removes hydrates from the process stream. Okay. Drum, a specialized type of storage tank or intermediary process vessels. Dryer, a vessel containing desiccant and screens across which process streams flow to have moisture removed. Okay. Filter, a device used to remove liquids, gas or solids, particulates from the process stream. So actually, ang ato ang mga terms diri nga needed sa ato ang discussion na meet na ninyo ni somehow, no, sa ato ang along the way sa ato ang pag-study aning chemical engineering. Okay. Then the fixed bed reactor, a reactor vessel in which the catalyst bed is stationary and the reactants are passed over it. In this type of reactor, the catalyst occupies a fixed position and is not designed to leave the reactor. Okay. Kasagaran ni mao ni siya mga AIX reactor, no? Kanang nasa mga water treatment. Okay? Steady lang ang iyang mga AIX kini ion exchange, no? Floating roof. So doon natin definition sa floating roof dere. A type of vessel covering type of vessel with maybe steel or plastic, no? Covering used on storage tanks. So vessel siya storage tank man, no? That floats upon the surface of the stored liquid and is used to decrease vapor space and reduce potential for evaporation. Okay. So ang ihang atop niya maglihok-lihok, no? Up and down, no? Dili siya fix. Okay. Then we have what is called fluidized bed reactor. A reactor that uses high velocity fluid to suspend or fluidize solid catalyst particles. Okay. Now foam chamber, a reservoir and piping installed on liquid storage vessels and containing fire extinguishing chemical foam. Gauge huts, an opening on the roof of a tank that is used to check tank levels and obtain samples of the tank contents. Heat tracing, a coil of heated wire or tubing that adheres to or is wrapped around a pipe in order to increase the temperature of the process fluid, reduce fluid viscosity, and facilitate flow. Manway, an opening in a vessel that permits entry for inspection and repair. Of course, of a man, no? Of a person. No? Mist eliminator, a device in the top of a tank composed of mist, veins, or fibers that collects droplets of mist from gas to prevent it from leaving the tank and moving forward with the process flow. So siya ang mukuha ng mga mist, no? Tawag siya mist eliminator. Mixer, a device used to mechanically combine chemicals or other substances, also known as an agitator. Pressurized tank, an enclosed vessel in which a greater than atmospheric pressure is maintained. Okay. Then, okay, W na no. Reaction furnace, a reactor that combines a fire box with tubing to provide heat for a reaction to occur inside the tubes. Reactor, a vessel in which chemical reactions are initiated and sustained. Spherical tank, vessel ni, a type of pressurized storage tank that is used to store volatile or highly pressurized material, also referred as round tanks. Okay. Stirred tank reactor, okay, reactor ni. A reactor vessel that contains a mixer or agitator to improve mixing of reactants. Sump, it is an area of temporary storage located at the bottom of a tank from which undesirable material is removed. Okay. Mura siya pit kung nasa gawas, pero siya kana sam ginagmay ra siya pero um, para gyapon siya sa mga waste ng product, no. Okay, tank, a large container or vessel for holding liquids and or gases. Tubular reactor, a continuously flowed vessel in which reactants are converted in relation to their position within the reactor tubes, not influenced by residence times in the reactor. Vein separator, a device composed of metal veins used to separate liquids from gases or solids from liquids. Then we have what is called vapor recovery system, the process of recapturing vapors by methods such as chilling or scrubbing. Vapors are then purified and the vapors or products are sent back to the process, sent to storage or recovered. No? Now vessel, which is our main topic, is a container in which materials are processed, treated, or stored. Okay. Vortex, the cone formed by swirling liquid or gas. Vortex breaker, a metal plate or similar device placed inside a cylindrical or cone-shaped or other type cooperating unit which prevents a vortex from being created as liquid is drawn out of the vessel. Mura po siya baffles, no? Where a flat or notch dam or barrier to liquid flow that is normally used either for the measurement of fluid flow or to maintain a given depth of fluid as on a tray of distillation column in a separator or other vessels. Okay? So, instrument na siya ha, kanang wear. Aron ma-measure nimo ang flow sa usa ka fluid, no? Okay, that's it, no? May nalimtan na ni. May nalimtan na ni, no? Okay. So, we'll go on to the types of vessels, no? Aton ang ganiha types of reactors to, no? Karon nata sa types of vessels, no? Now, vessels are a vital part of the operational units in the process industries. A vessel is a container in which materials are processed, treated, or stored as defined, no? Mao na ka definition nato. Without this type of equipment, the process industries would be unable to create and store large amounts of products. So, yan lang katigot guys ha kung sa pag-differentiate sa reactors of vessels, no? Now, vessels include tanks, towers, reactors, drums, dryers, cylinders, hoppers, bins, and other similar containers that are used to process or store materials. Vessels vary greatly in design, size, and shape. So, based on the requirement of the process, factors that affect vessel design includes pressure requirements, type of products contained in the vessel, temperature requirements, and corrosion factors. Ato na ning gibalik din, no? Ato na ning gibalik vessel ganihan, no? Okay. Okay. So by using tanks to store products in large quantities, companies can maximize both cost effectiveness and efficiency. Drums are used both for process mainstream application and for auxiliary process applications. Okay, so reactor, how many reactor ani? So reactors are used to provide a chemical reaction that some processes require to create the end product. Dryers are desiccants, no? Specialized substances containing a dryer that remove hydrates from the process stream. Okay, so in our diagram there we have the drum. It includes vacuum, pressurized or atmospheric, no? PD vented, PD pod pressurized. Then we have our filter, wa siya mabutang diri. Ito example, reactor ato na lang gi-discuss. Then we have towers, no? So reactor, by the way, reactor is a type of vessels, no? Okay. Now tower, we have pressurized or atmospheric, no? We have also a vacuum tower, no? And the tank, may pinaka common yun sa vessels, no? We have above ground or underground. So above ground we have pressurized. So under sa pressurized we have bullet cylinder, spare cylinder or spheroid cylinder, no? Okay. Now under above ground gihapon we have what is called atmospheric or low pressure. We have what is called fixed roof and the floating roof. Under the floating roof we have external floating roof, we have internal floating roof. Okay? We don't have example of the tank, kasagarang tank nga nasa underground, ang kanarang mga gasoline tank, no? Ang gasolinahan na sila ang tayuta na sila gibutang for safety purposes, no? Okay? So, let's proceed. So, the purpose of vessels. Vessels are used to carry out process operations such as distillation, drying, filtration, stripping, and reaction. Okay? These operations usually involve many different types of vessels, ranging from large towers to small additive and waste collection drums. Vessels are also used to provide intermediate storage between processing steps. They can provide residence time for reactions to complete or for content to settle. A storage tank is a common type of vessel because every process requires a containers to hold feed and other materials. Tanks are used for raw materials and additives, intermediate products, final products, and waste or non-recoverable off-peak products and byproducts. Okay. A drum is used for the collection and separation of material in processes for storage and for the separation of materials before furthering processing. Drums operate either under greater than atmospheric pressure or under vacuum pressure. Okay. A dryer removes moisture from process streams. Dryers ensure that hydrates do not reach the lower temperature section of a process plant, such as distillation, or that hydrates are kept from processes that react with moisture. Then a filter is used to remove liquid, gas, or solid particulates from the process stream. Filters help prevent damage to downstream equipment. Then bins or hoppers typically hold dry solid. Kasagaran na ni siya sa mga quarrying areas, no? Kanang mag-burn, no? Mag-grind og mga solid for further processing, no? Ibutan siya sa bin, no? Kanang kuan diha niagi na nag-drying, no? Dili na siya, sirado na siya, no? Walay moisture makasulod. Okay? So, these are the diagrams, so the types of tanks, no? So kini siya mo ni example sa floating roof atmospheric tank. Okay? So ang iyang tabon din gikat man ni siya, no? Kanang floating roof niya magirog-irog na, no? Up and down, no? But we have a seal, no? nakasil siya around perimeter. Doon siya nakasil siya around dili siya masudlan og air unsa diha, no? Okay? So we have articulated roof drain. And the bottom, okay, we have the roof drain guides in the outside shell. So very simple ra kayo nga to ang kuan to, no, ang floating roof atmospheric tank, no. Then we have the second part is the closed tank, no. Mao na sila ang spherical type, the cylindrical or valley type. Moram siya cylindrical kanang cylinder siya pero ang yang end part niya is hemisphere, no. Then we have what is called hemispheroid. Ang hemispheroid mura po siya og valley type or cylindrical type pero usa ra ka part niya ang hemisphere, ang other part niya is flat bottom, no. Okay, and then spherical tank, kaduha ni example dito yung spherical tank, no. Okay, so kailan tulong so paisan ning tulo na to ka singin ani example. So a pressurized tank is enclosed vessel in which pressure greater than atmospheric pressure is maintained, no. Dapat kining mga sirado taas sila mga pressure, no. Okay, okay, man naman siguro ito nin pa din, no. Floating roof, a steel or plastic roof used on storage tanks. It floats upon the surface of the stored liquid and is used to decrease vapor space and reduce potential for evaporation. Okay, kaya may space, no? So, di siya ka-evaporate, no? So, floating roofs can be either internal or external. They use a flexible seal to prevent leakage. So, ang iyang takob nakalutaw sa ibabaw sa liquid, no? Sa sulod sa tangke. Now, because of the design, floating roofs are not appropriate for pressurized fluids. Atmospheric naman siya, no? Then we have what is called articulated drain. It is a hinge drain attached to the roof of an external floating roof tank, which removes water from the roof. An articulated drain moves up and down as the roof and the fluid levels rise and fall. Blanketing is the process of putting an inert gas, usually nitrogen, into the vapor space above the liquid in a tank to prevent air leakage into the tank. Okay, so common components of vessels. We have what is called blanketing, no? So a tank reduces the amount of oxygen present and decreases the risk of fire and explosion. Kaya gisiradan man siya, no? Giblanket man siya. So wala na oxygen from air, no? Blankets are reduce the risk of tank implosion or collapsing, no? By preventing a vacuum from being created as the tank is being emptied. So figure 15.5 shows an example of a tank blanketed with an inert gas, no? So nga to ang blanketing gas na si babaw, no? Atong hydrocarbons na si ilawom. So ang hydrocarbons, you know, hydrocarbons are very flammable kay siya, no? So wa may air, no? Wa may oxygen makasud, dili siya delikado, no? We have also what is called a foam chamber. A foam chamber, a reservoir and piping installed on liquid storage vessels which contain chemical foam used to extinguish fires within a tank. Okay, figure 15.6. Okay, so foam chambers putting out a fire. So doon natay pwedeng nasunog siya pero doon natay foam chamber, automatic siya mogawas, no? Ang foam chamber mura na siya og usually good gigamit ang foam para sa mga electrical or sa diya kanang highly luminous nga highly flammable nga mga substances para dali ra siya mapaong dayon, no? So mura po siya og mo blanket gihapon. Okay, sump. Okay, ato na ning gidiscuss kaniya. An area located at the bottom of a vessel that receives and temporarily stores drainage from the lowest point in that vessel. So figure 15.7. So asa mga itong drain sump. So nasa ubos, no? Nasa ubos. Mura mo siya crankcase, no? Crankcase o sa kamakina, no? Na dito ang mga hugaw sa asiti o gikan kinaon sa makina, no? So that is the drain sump. Okay? Mixer, a device used to stir chemicals or other substances. Mixers can be mounted vertically or horizontally in a vessel. Mixers can be operated at the tank site using motors located outside the vessel or by started remotely, depending the type of service, no? Figure 15.8 is one, no? So mo na tong mixer, so klaro do natay blade sa ilawom, no? In this case duha pa gyud ang blade, no? Sometimes ang blade sa usa mas longer kaysa pikas sa usa, no? Depende sa type sa ato ang mixer. Okay? So gauge huts, an opening on the roof of a tank that is used to check tank levels and obtain samples of the tank contains. Figure 15.9. So mo na siya ay gauge huts, no? An opening on, pwede rin na siya abliho, no? Para mag-check sa tank levels, no? Or magkuha ka og samples, no? Okay. Manway, an opening in a vessel that permits human entry for inspection and maintenance or repair. Most manways are flange openings located on the roof or side of a tank. Figure 15.1. So, ingon na ang manway, no? Okay. Sirado kay na, pero pag during ablihan na siya, usasahong yung tangtang ang bolt tanan niya. Okay. Heat tracing. A coil, what example there? A coil of heated wire or tubing that adheres to or is wrapped around a pipe in order to maintain or increase the temperature of the process fluid, reduce fluid viscosity, and facilitate flow. Both steam and electrical types of heat tracing are used. Process piping using a heat tracing system is covered with thermal insulation to help maintain its temperature and also to protect personnel from burn injury. Okay, so before recovery system, the process of capturing evaporated fluid or vapors in the tank for recycling into the system or for use in another area. This method employs processes such as chilling or scrubbing. The recaptured materials are then purified and the vapors or products are sent back to the process. Okay. So vortex breaker. So mo yung vortex breaker, no? Mo yung forman niya. Ano sa kasagaran ni butang sa tunga-tunga sa kanang tangke nimo kung nakatapered siya, no? Okay. A metal plate or similar device placed on the drain line of a cylindrical or cone-shaped vessels. It prevents a vortex from being created as liquid is drawn out of the tank. A vortex is the cone formed by swirling liquid or gas. Vortex breakers are used to create a more linear flow from the tank and to prevent pump cavitation. Vortex breakers are also used in other vessels that need to maintain a constant flow through the equipment. Okay. So, baffle. Mo ng baffle, no? A metal plate placed at a strategic position inside a vessel that alters the flow of the material in the vessels and can help to facilitate mixing. Wear, asan ang wear ani? Tara, no? A wear is a gadget, no? A flat or notched dam or barrier to liquid flow that is normally used either to measure fluid flows or maintain a given depth of fluid. Figure 15.4, so mo siya, no? The example, anything that is above the wear flows above the wear flows over, so mag-overflow, no? Okay. Now, in this example, oil is lighter than water. It overflows the wear and is removed as the heavier component out of the bottom. Because gasoline is also lighter than water, gasoline overflows the wear and is removed as gas out the top. This wear is used to separate three substances: oil, gasoline, and water. So ang mag-overflow niya, oil, gasoline. Ang water is sa pikas, ang mo overflow niya is oil and gas, no? Gasoline. Okay. Both. Okay. A section at the bottom of a process vessel where water is or other unwanted fluid is collected and removed. This area is located at the lowest section of the vessel. So mo na siya ang boat, no? Kita ka na naka-red color niya, mo na siya ang draw off boat. Okay? So naka-hydrocarbons niya doon na siya mura siya og trap nga canals, no? Sa ilawom, no? Ang bugat man ang tubig, so ana diya ang tubig mo pondo. Okay? Tawag siya og boat. Mist eliminator, a device placed in the top of a tank composed of lawa na kung butang da natay sample ani of mesh, veins or fibers that collects droplets or mist from gas to prevent it from leaving the tank and moving forward with the process flow. Okay? Both a vein separator human na day, no? Ato na nang gi-define. Okay. So OSHA requires all above ground tanks to have a containment system built around them for personal and environmental safety in case of leaks, spills, or other incidents. A containment system usually made from earth or concrete can take the form of a dike, firewall, or containment wall. A containment wall or dike is a wall used to protect the environment and people against tank failures, fires, runoff, and spills. It can be earthen, masonry, steel, or concrete. Containment wall must be high enough to hold the entire containment of the largest tank within the enclosed area. So, mo na ang figure na to, no? Mo na ito ang diagram, no? So, taas kayo, no? Ang iyang containment wall diha, mura na nagbubo pero taas kay na. Kana siyang iyang gibutangan diha og kanang kuan mo na siyang gitawag na to og bins, no? Bin na siya. Katong storage bitaw sa mga dry nga mga product, no? Like for example, nag-grind na nga mga kuan earth, no? Mga ore. So, a containment system serves several functions, no? Contains chemical spills in a small area in order to minimize safety risk, untrap contaminants and or hazardous materials before they can spread to other areas. So, gilihan siya mura siya og kanang ali lang, no? It protects the soil, water, and the environment from contaminants, no? Protects humans also, no, from potential hazards. Example like chemical release, no? Contains wastewater and contaminated rainwater until it can either be drained into a proper process sewer system line or be vacuumed from the area. It protects also against the spread of fires. So, ano siya firewall, no? Containment wall is a firewall. With certain types of tanks, in the event of heavy rainfall, technician must open a valve and drain the liquid from within the containment wall to prevent the tank from flooding, no? The rainfall buildup must be tested to be free of contaminants prior to draining. Okay. So, a reactor is a vessel in which, okay, manatag-define na nato ni, no? Ibalik lang nato ni. Okay. So, as third tank reactor, ato na ning gi-define sa ato ang mga reactor. So, this is the third tank reactor. Mo ni ato ang i-design, no? Reactor. Don't forget ha, reactor is part of a vessel, no? Type of a vessel siya, ang reactor. Okay. Then we have a fixed bed reactor. Mo ni ang design. Doon na siya mga beads, no? Okay. Then FBR, no? Fluidized bed reactor uses high velocity fluid to suspend and separate solids. The reactor feed is mixed with suspended catalyst where the reaction takes place. Ato na ning na-discuss kagani ha. Tubular reactor ato na po nang na-discuss. Okay. Okay, so kung ikaw ang kuan technician, process technician, in order to accurately locate vessels and reactors on a piping and instrumentation, process technicians need to be familiar with the symbols that represent different types of tanks, no? Like the drums. How many drums there? Huh? Vessels, reactors, no? Okay, example of vessel symbols. Ang bin, ano siya forma niya. So makita taging na nga symbol, that is bin. Kung ingon na ang symbol niya nga mura siya og na hemisphere sa both ends, reactor na. Then hemispheroid, mura po siya reactor pero usaray yang hemisphere niya, no? Then open roof tank, kato ni siyang mirugiro iyang takob, no? Then tank, kanang simple nga tank lang. So we have also the internal floating roof tank. We have a double wall tank, cylindrical or bullet type. Then the spare, no? Literally spare, lingin ko siya, murag bula, no? Then we have also what is called elliptical tank, no? Spheroid. Then we have what is called atmospheric tank and the external floating roof tank. So mo na yung mga mga symbols niya. So those are the vessel symbols. Okay guys, so this is the last part of our discussion. So puro ra tangki, no? Tangki, the differentiation sa vessels o sa ato ang reactors, and also defining the chemical reaction engineering. Unsa gina siya, unsa atong trabaho diya, no, as a chemical engineer. So all these things are just mga basic lang, no, mga theories nga kuan. So next part, mag-start ta sa ato ang mole balances, no. Then hopefully maka-derive ta sa atong equation. Padulong na tangad to sa usa sa katang, no. Madto, so mag-design sa tang unsa na to pagkuan sa atong kinetics, mag-review pa ta kay part na sa atong pag-review na to. Okay? So that's it guys. Please open your microphone for the second. Dadawi aton tanang napabisulan niya. Okay, so we'll discuss this later, no, sa sunod na natin ipang-discuss. Okay. So please open your mic for the second attendance, okay? Abarkis. Wag yun ni. Abrasaldo.
Na.
Abarkis na ah? Hello.
Yes, sir. Hello.
Abarkis na ah?
Sir.
Nalit ka Abarkis? Wala.
Mga 5 minutes, sir.
5 minutes. Sige, ato lang nang i-remove. Madapa na. Abrasaldo may? Abrasaldo. Wajud ni no? Ansita.
Present, sir.
Okay. Arong.
Present, sir.
Arius. Wajud. Bilbistri.
Present, sir.
Kanyete. Kanyete Hana. Von. Mara na siya German. Hana Von. Kanyete. Wajud. Caballero. Saidil.
Present, sir.
Castañares. Shimi.
Present, sir.
Pimente. Shadrina.
Present, sir.
Koyos.
Present, sir.
Akay.
Present, sir.
Glasa. Mahatma.
Present, sir.
Dinopol, our president. Dinopol Jade. Nawaha man. Naas Dinopol Jade.
Naara si Jade,
Naa,
sir.
sir.
Na, di siya mutingog, awa katingog. Durham.
Present, sir.
John Scario.
Present,
John.
sir. Present,
Fabric.
sir.
Fabric. Fabric kide. Fabric.
Present, sir. Present, sir.
Figueroa. Yes. Figueroa.
Present, sir. Present.
Gilina. Giliena.
Press.
Harina. Harina. Wala, nawagtang. Harina wa.
Na-disconnect siguro, sir.
Lagroma. Sige lang, mo
Present, sir.
Leopando.
Sir, present. Jarina, sir.
Kisay present si?
Jarina, sir.
Jarina din dili Harina. Sorry.
Ay, okay, sir.
Sir Barrios, sir, present.
Barrios.
Kanyete food, sir. Present,
Di mo
sir.
kaniha Barrios. Late ka,
Sir,
wala.
na-brown out ka diyo. Ay, ganina, sir, nakasulod ko, sir, 3/20/14.
14? Sige.
Oo.
Isa pa may
Naka-chat ko sa
nakasulod niya si
3:20.
Kanyete. Wa ni?
Kanyete, yes, sir.
Tiluan po,
Na,
sir.
Late ka
Present
Kanyete.
sir. Oh, sir, connecting ko na, sir. Dugay ko kasud.
Sige. Ato na lang tangtangon kay first meeting naman. Bati man ang pilditi ron kay pilditi gani ako kuan. Dili kayo sa ni. Abrasaldo. Wa jud na no. So Jarina din ni. Lagroma no. Leopando,
Present, sir.
Luwab. Wa ni.
Present, present, sir. Na late ko ganiha, sir. Mga 3:14 ako naka-message, sir, kay hinay kay ang net.
340 siya to lang sa nang tanggalon. Lumibaw.
Present,
Lumibaw.
sir.
Miuli.
Present, sir.
Unsay pag-pronounce na imong kuan? Family name? Samantha?
Ngole, sir.
Miuli? Miuli, okay.
Oo. Present ko ganina, sir. Thank you.
Sige, Morok.
Present, sir.
Nervida.
Present, sir. Present,
Palis?
Nervida.
Okay, Palis. What is Palis?
Hello, sir. Present, sir.
Ito. Sabin. What yun, no? Perez. Perez, wa? Ay man si Perez. Prandas.
Present, sir.
Ponte.
Present, sir.
Rubin.
Present,
Rubin.
sir.
Sanoy.
Present, sir.
Present, sir,
Silya.
Sanoy.
Sinilio.
Present, sir, Sinilio.
Susun, wa jud ni?
Present, sir, Susan.
Late ka?
Yes, sir. Late ko, sir.
Ato lang sa tantangon ang late karon ha kay first meeting pa man nato. Toledo, wa jud ni?
Present, sir.
Vergara.
Present, sir.
Yaon.
Present, sir.
Okay, so that's it guys. Ang tomorrow siguro mag-discuss na ta sa mga mall balances lang o sa ano. Hinahinit ano dito mo dito din sa kuan. Maybe we have everyday man ang ato ang kuan. So tomorrow will be discuss sa 4:30 na ta no, 2 hours na siya. So okay. So don't forget nga every Monday lang ang ato ang quiz no. Okay ra ba ka ninyo na? Di ba taas na kayo? Ha? Taas na siguro no? Murag taas siguro kayong every Monday. O resipalitan nato ning quiz ato ang kuan sa ato ang theories, no? Ha? Sipalitan siguro nato ning quiz atong theories kay aron di ta maguna nagdaghang kaayo nga quiz. Okay? So tomorrow we'll have a discussion sa ato ang kuan, no, mole balances. Maybe by Friday na lang mag-quiz lang kog kausa sa ato ang theories lang, no. Not the competition. Ang competition diri na sa mga every Monday na to gamiton, no. Okay? Pindi na lang, no, sa agreement na to, okay?
Excuse me, sir.
Yes, kinsa ron?
Present po si Perez, sir.
Perez?
Brown out kat sa ila o. Yan ni chat man siya, sir, katong pag unang attendance.
Okay,
Ni chat
sige,
siya
sige.
diri sa call.
Perez? Sige, sige. So, Pipito na lang ang nabilin og si Abrasaldo Maywa. Okay, so that's it, guys, no? So if you do not have any questions na, you can log out now. Okay, so God bless.
Thank you, sir.
Okay,
Yes,
you're
sir.
welcome.
Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.